Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a review of graphing quadratics using the vertex, okay, by finding the vertex first and using the axis symmetry and finding the x-intercepts. This is all based upon lesson 7.3, so pause the video and get lesson 7.3 out. We did about 10 examples in there. So get that out, have it side by side, get your red pen and pencil out. Here we go. The very first thing you have to realize here is that we have a function in factored form. Okay, and in factored form you cannot determine what A, B, and C are to determine the vertex. So what you need to do is go from factored form to standard form. All right, standard form is y equals a times x squared plus bx plus c. All right, and so the very first thing we're going to do is use FOIL. We're going to multiply the binomials and get it in standard form so we can determine A, B, and C. So we're going to have y equals x plus 3 times x minus 1. I'm going to distribute. Here we go. So y equals x squared minus x. So that's x squared minus x plus 3x minus 3. Collecting like terms, I have y equals x squared. 3 minus 1 is 2, so plus 2x minus 3. So in this case, A is 1, B is 2, C is negative 3. So let me record those values down here so we can get started. So A equals 1, B equals 2. Those are the two values you need. C, not needed for this right here for the vertex, but I'm going to write it down anyways. All right, that's called standard form, where you can see A, B, and C. We went from factored to standard. So factored form is right here, and then standard form right here. Okay, right there. So let's go ahead and find the not only the axis symmetry but also the x-coordinate of the vertex, and it's always found by taking negative of b, so negative of 2, all right, divided by 2 times a, which is 1. Well, that's negative 2 divided by 2, which is negative 1. Find y, you substitute it back into the function. You take your x value, substitute it back to find y. So y is equal to, and you can substitute it in standard form or factor form, whatever you wish. I'm going to use factor form, it's easier. So negative 1 plus 3 times negative 1 minus 1. Can't be any easier than that. So y is equal to 2 times negative 2, or y equals negative 4. So my vertex, which is always x comma y, my vertex here is negative 1 comma negative 4. So I plot that first. Negative 1, negative 4 is right here. And I have the vertex there. I draw the line of symmetry to help me graph. It goes right through the vertex every single time. All right, so then I got my axis symmetry, goes through negative 1 right here. So it's x equals negative 1. And then I start my graphing, right? So I have this point of the vertex right here. And then from there, I can go right one, up one, right two, up four, and so on. Or I can get some values, okay? And when I first taught this, I'm going to put the vertex right here, negative 1, negative 4. I said just pick a few x values to the right of negative 1. All right, the first integer to the right. Well, the first integer to the right is 0, and then 1, and then 2, and then 3, and so on. So if you didn't know that this was similar to the parent function y equals x squared, and you didn't know its parent values, then you would substitute some points in, like 0. So y equals 0 plus 3 times 0 minus 1. That's 3 times negative 1, or negative 3. So 0, negative 3 is a point on the graph, which is right one, up one. And then you reflect it, just like that. And then you pick another value to the right, okay, and that's 1. So you have, you're going to substitute in two locations, right? So you have, let's see, 1 plus 3 times 1 minus 1. That's 4 times 0, or obviously 0. So 1 comma 0 is on the graph. So you go up here and you plot 1 comma 0, which is right here. All right, it's 2 units away, so you reflect it and goes 2 units on the other side. So reflect it, and then you draw your graph. Or you can use the parent values. Right 1, up 1 from the vertex, right 2, up 4. All right, they're a smooth U-shaped function. They get wider as they get taller, so make sure you draw it that way. Okay, and as you can tell, I have an x-intercept here at 1 comma 0. That's pretty evident. And we have another one right here. I have another x-intercept at negative 3 comma 0. Negative 3 comma 0. Remember, y-intercepts are points where y equals 0, and that's why I said set y equals 0 and solve for the x algebraically. Okay, so what I'm going to do is do that and prove that these x-intercepts are the real ones. So we're going to have our functions y equals x plus 3 times x minus 1. We set 0 in for y, look right there. So we have 0 in. And there's no work to be done here because it's already in factored form, so you don't need to factor it. You just set each factor equal to 0 and solve using the zero product rule. Zero product rule. If you have a product equal to 0, one of them has to be equal to 0. So that's why I said set each factor, they're called factors, equal to 0 and solve. All right, so we have to solve x plus 3 equals 0, and we have to solve x minus 1 equals 0. Well, here x has to be negative 3, and here x is equal to 1. And guess what? They're right here. These are the x values. So these x values here correspond with these. And if you look closely on the graph, okay, that's where this is 1. This is right here is at negative 3. They correspond to these numbers here. So these numbers here that we solved algebraically correspond to the x-intercepts in our ordered pairs here, which correspond to the values on the graph where they intersect the x-axis. Okay. Now, for parabolas open up and down, as you guys already know, the domain is all reals. All right. Not true for parabolas opening up left and right. The range depends on the minimum value here. Y minimum equals negative 4, so all the other y values are above it or greater than or equal to it. So y is greater than or equal to negative 4. That's all there is to it. So let's get some more experience here, and let's work with a couple other ones. You have 3 to do in this review. Now here, we start off with standard form. So y equals ax squared plus bx plus c. So I can already see that a is 1, b is negative 2, c is 3. So from here, you determine your values. This is standard form. And what we want to do is find the vertex, the same way we did in the previous problem. So we take our values, take these a and b values, substitute them in. So you get to take opposite of b, negative 2, divided by 2 times 1, 2 times a. That's 2 divided by 2, or 1. Then to find y, you take this and you substitute it back, right? That's how you always find y, you substitute it back. So y is equal to 1 squared minus 2 times 1 plus 3. So 1 minus 2 plus 3, what's that? So it's negative 1 plus 3 is 2. So y equals 2. So the vertex is 1 comma 2. So write one up 2. Draw your line of symmetry. Okay, there you go. And then you pick a value to the right, like 0 and 1. So the vertex is 1 comma 2. So pick a value to the right. First, oops, backwards. First, integer to the right. That's what you do. It's what you pick in the table. All right, and that's 0. So y equals 0 squared minus 2 times 0 plus 3. That's obviously 3 because these cancel out, right? So 0 comma 3. So you plot that and reflect it. So here we go. 0 comma 3 is right here, and you reflect it. There we go. Got 2 more points. We got a minimum of 5 though. So let's pick another value, like 1. Y equals 1 squared minus 2 times 1 plus 3. Y equals 1 minus 2 plus 3. Y equals negative 1 plus 3 is 2. So y equals 2. So 1 comma 2. Oh, I didn't do that right. What happened here? See, negative 1, 0, 3. 1 minus, what's going on here? Something's wrong. Where's my mistake here? Oh, I have no mistake. Oh, you know, I didn't even plot that correctly here. 1 comma 2 is on the other side, obviously. So let me regraph here. That's my mistake. Sorry, guys. I know. It's early in the morning. So 1 comma 2 is here. Okay, there we go. X symmetry here at x equals 1. No, 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 no. Okay, there we go. My point that I graphed earlier was 0, 3. Reflect it over here. And there we go. Okay, 1 comma 2. I don't know why I picked the 1 comma 2. I should have picked 2. That's what I should have picked. So y equals 2 squared minus 2 times 2 plus 3. That's 4 minus 4. These cancel. You get 3. So 2 comma 3. There we go. That's better. 2 comma 3 is right here. So how about another one? Let's pick 3. So y equals 3 squared minus 2 times 3 plus 3. 9 minus 6 plus 3. 3 plus 3 is 6, so 3 comma 6. There we go. So 3 comma 6. So write 3 up. 1, 2, 3, 4, 5, 6. Notice that we could have used the parent values because this right here, its parent was y equals x squared, and you guys already had the parent values memorized. So from the vertex, I could go write 1 up 1, write 2 up 4, and then reflect. Boom, right there. And then you just draw your curve. Okay. So there, notice that the parabola does not intersect the x-axis, right? So parabola does not intersect x-axis. Intersect the x-axis. And because of that, all right, there are no x-intercepts. There are none. The only way it can have x-intercepts is if it intersects or meets or crosses the x-axis. And that's why if you tried to solve this right here for the x-intercepts, and you set y equal to 0 and solve, watch what happens. Okay. Now this one here, if you try to solve for them, do you know two numbers that multiply to 3 and add to -2? And I don't either. It's not factorable. Okay, because it's not factorable, you have to use quadratic formula. So use quadratic formula or completing the square, one of the two. Now I'm just going to use the quadratic formula. So x is equal to opposite of b, negative b plus or minus the square root b squared minus 4ac all divided by 2a. So x is equal to negative b, which is -2, so negative of -2 plus or minus the square root of -2 squared minus 4 times a, which is 1, times c, which is 3, all divided by 2 times 1. So I get 2 plus or minus the square root, 4 minus 12, all divided by 2. And this is equal to 2 plus or minus the square root of -8 divided by 2. The only issue is that this right here is not real. Okay, not a real number. So no real solution. Okay, and that tells me that there are no x-intercepts. That's why I said there are none, because there are none, guys. This parabola doesn't intersect the x-axis. So even if you try to solve them by setting y equal to 0, you're not going to find any, guys. So the only thing you do is state the domain, which is the set of all reals. Go back up to the graph and see this is a minimum. So it's y minimum is equal to 2. That means all the other y values have got to be greater than or equal to it. So greater than or equal to 2. And that's all there is to it. Ba-bum, 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 right there. Go ahead and just take a look at that. Do your best. Okay, one more in the review. So let's go to the next and the last page right here, and then we'll go to the second review, our last review, because this only is part of it. Okay. So here we're going to convert this to vertex form. So y equals x squared plus 4x plus 3, which is in standard form. This is standard. It's called standard form. As you guys already know, y equals ax squared plus bx plus c. So we're going to get into vertex form. Ooh, right there. Okay, so here we go. We're going to subtract 3. This is the other way you can graph a parabola. This is the way I like to do it. Instead of using negative b divided by 2a, I get in this vertex form and then graph it using the parent values. I'm going to complete the square. So b is 4. So it's b divided by 2 quantity squared. All right, to complete the square. That's 4 divided by 2 squared, or 2 squared, or 4. So I'm going to add the 4 here. Let me see. We're going to have to leave room here. So let's see here. Let me redo this here. Plus blank equals x squared plus 4x plus blank. All right. So I'm going to add the 4 here and here. I can complete the square, by the way, because the lead coefficient is 1. It's 1 right there. All right, negative 3 plus 4 is positive 1, so let's have y plus 1 is equal to x squared. Now I got to factor what two numbers multiply to 4 and add to 4, and they're 2 and 2, so you got to split the middle term. All right, do x plus 2x plus 4. I found the factors. Two numbers that multiply to 4 and add to 4 are 2 and 2, so you split the factor by grouping. Factor out the 2. And you get y plus 1 is equal to x plus 2 times itself. The common binomial right here was factored out, and I multiplied it by the remaining factors right here, x plus 2. Rewrite. And then get in vertex form. So you have y equals x plus 2 to the second power minus 1. Here, if you look at vertex form right underneath it, you could see a is 1, so a equals 1. So it acts like your parent function right here, y equals x squared. There's your parent. And then it opens up, because it's positive, opens up. And then you need to state the vertex here at, let me see what the vertex is. Let's see, h has to be negative 2. X minus a negative 2 is x plus 2. So it's negative 2 comma negative 1. So we're going to start there. So negative 2, negative 1 is right here. So you plot the vertex, and you also draw that what's called the line of symmetry, and then graph from there. Okay, so using the parent values, you go right 1, up 1, and then reflect right here, and then right 2, 4, 1, 2, 3, 4, and then reflect, and then right 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then reflect on the other side, and you graph your parabola. Nice, smooth U-shaped function. Ooh, a little smoother than that. Okay, there we go. All right, and then the last thing we want to do is graph or find the x-intercepts. We could use vertex form, or we can use the standard form, doesn't matter. So I'm just going to take the x squared plus 4x plus 3 down here. Y equals x squared plus 4x plus 3. I'm going to set y equal to 0. That's how you solve for the x-intercepts, which are here. I can already see them on the graph. It's negative 1 comma 0, and at negative 1, this is a negative 3. So this one here at negative 3 comma 0, another x-intercept. So I can already see them. I know what they are, negative 1, 3, but let's make sure we get them. So what I'm going to do is factor. All right. I know two numbers that multiply to 3 and add to 4, so I can play the factor game really easily here. They're 1 and 3. 1 times 3 is 3, and 1 plus 3 is 4. So I can factor. So I've got, whoa, let me put that back there. So I got x squared plus. So I can factor and by grouping, so I'm going to split the middle term. Notice that 1x plus 3x is 4x, so split the middle term. Do a little factor by grouping here. Factor out of 3. So notice that the common binomial in this case is x plus 1, so factor it out. Multiply it by the remaining terms, x plus 3. and I have what's called a zero product. Once you have a zero product, you set each factor equal to 0 and solve them. Oh, that's not Spanish. Let me see. Zero product right there. There we go. So you set each one equal to 0. So x plus 1 equals 0. The next one, x plus 3, could be 0. Here, x equals -1. Over here, it's -3. And notice they correspond to these numbers here. -1 right here and -3. Same values, same x-intercepts. All right. So you see above in the graph. To check. They make sense. Okay, the domain, set of all reals, range, well, it depends on this right here. It's a minimum, so y minimum is equal to -1. That tells me that all the other y values are greater than or equal to -1. Axis symmetry goes through -2 right here, so x equals -2. And that's all there is to it, my friends. All right, you just have to review and work hard, and I'll see you in my next lesson. This is Mr. Ainsworth. See you later.